զգացվածի։ Բարև ձեզ։ Այսօրվա ելույթը անգլերեն լեզվով ալինելու, բայց ովքեր անգլերենով դժվարանում են, նույն պրեզենտացիան մեր օֆիսում տեղի ունեցել, հայերեն ձայնագրությունը կա, այս վիդեոյի հետ դա էլ կդրվի, լինքը կդնեմ, որ ովքեր որ ուզում են հայերենով նայեն։ Okay? Now we will continue in English. So, thank you everyone for coming for my presentation. I'm a bit nervous because this is my first English language talk, and so please bear with me. I may make some mistakes. So today's presentation is about very, very simple things, about very fundamental things, and about very basic things. They're very basic, that's why no one cares about them. Yeah? Everyone thinks this is basic and just goes away. And those are principles of writing good code. Those are principles of writing code that will live longer. And I will share my view, my experience, and experience of other people that I have read from the books. Most of the things I will tell here are written in the books, but as I know that people don't really like reading big books, that's why I want to present it in a simple way. And I want to say that there will be no complex things. And the problem resides inside of those basic principles. They are basic, that's why people tend to forget it. And it's really easy to understand those principles, but it's really difficult to follow them. Yeah? From our experience of writing JavaScript for a long period of time, for many years, I have come to a conclusion that the fundamental unit of a program is a function. And if you can write a good function, one single function, and if you have like more concentration of writing one good single function, then the whole code you are writing will be good also. Yeah? So, and all you need is functions, a lot of functions. I'm thinking that JavaScript is much more functional programming language than like object-oriented or other I don't know what kind of languages. And that's why writing good functions in JavaScript is really a challenge. You know that JavaScript, as Ruben mentioned, has been written in 10 days. That's why a lot of people, it's really easy to write in JavaScript, but it's really easy to write bad code in JavaScript. Yeah? And the principles I'm going to tell you, those are universal for every programming language. Like 90% of principles that will be presented here, they are universal and doesn't really matter you are writing on Java, you're writing in C++, or in other languages. If you keep those principles, then you will have better code and you will like yourself, okay? So, this talk is for, yeah? This is the agenda or the contents. It's about the good function, the naming, the arguments, the purity of a function, the composition, and a little bit about arrays and about particular implementation of some functions, okay? So, first of all, I want to mention that this code is not for people who are writing programs for NASA, okay? This is not the case. Who are writing code for like trading agencies, where the millisecond is an important time, or the nanosecond matters, okay? Have this in mind, because going forward, when I will tell you some things, you might think, but that's not optimal, but it's a little bit longer, but you are going through the array 2 times instead of 1 time. That's why I want to mention it in the first place. This is not for people who are writing code for milliseconds. But this is for developers who are work in teams, write programs that are intended to work for many years. It's not a one-time code. And who want to write programs as a poetry and who want to experience multi-dimensional universes. Yeah. First of all, the function names. Now let's explore a couple of names. hex string to HSV and color. Yeah, whoever is familiar with HTML or so, it's pretty straightforward. You are giving him color, he gives you an X string. Get saturation over rectangular. Name says what it does. It has the argument, nothing confusing. Going forward, rotate by. You give the rectangle, you give the angle, it rotates it. You cannot confuse it. Calculate discount. You give the price, you give the discount, it calculates the discount. No questions yet? Media path, file path, blank. What? Does anyone understand what is written here? Like what the function will do? Will it return the file path? Will it generate file path? Will it what? Those are function. Oops. Those are function names from our code base, basically. We do also write a lot of bad code. Yeah, we are not saints. So this is a particular example of a bad function. Is even, and the number. Is the number even or not? This function name also helps you, and it gives you a feeling that you will receive eventually the Boolean argument, the Boolean type, true or false. Straightforward function name. A good example. Get things done on the object. Do you like those kind of functions? Have you wrote those kind of functions, or have you seen in your code like some programmer wanted to do some good stuff, and it's really doing great stuff, but you don't know what kind of stuff, okay? Another example. Make nicer this data. Do what? Nicer. Whatever that means, yeah, whatever that means for the developer. Another example, toggle modal, which receives data, name, ID, and I assume is show, like to show or not to show. This is not a real life example. It's an exaggeration. But there are a lot of times when we tend to overload function with useless parameters or with many parameters, or we write down toggle, but then still we are sending Boolean argument to show or not to show. Yeah? But the toggle is intended for swapping the case, flipping. If it's shown, hide. If it's hidden, show. But in the end, we are getting this kind of weird function names. Another bad name example, again from our code base. So get screen count. Can you see the screen? Yeah? It's a get screen count for the particular template. But then you see that it does not return you number of screens. It returns you the same templates with edit screen number. So the weirdest thing that we tend to do a lot of times is that we're writing the function name get. But when you look inside, you see that this function goes to database, grabs something, updates something, removes something, and then returns another thing. But you need to remember, if it's get, it should not change any state of anything. It's just get, okay? Get is get. So here is like a ridiculous problem, not only with the name, but with the body. And it is not fair. It doesn't tell you what he's doing, and it does really weird stuff. Instead of returning screens count, it returns you the template again. About the function, about function names, I think the easy and the straightforward advice is that you tend to write whatever function is doing. If it does two things, sometimes you cannot separate them. You're writing get and update some object, or insert and sanitize, or whatever. But you straightforwardly, you state what you are doing inside the function. Yes? I'm still thinking that doing two things inside of a function is a bad thing. But when you don't have any other choice, at least you must write that down in the name of a function. Let it be a bit longer, but it should describe what is inside of a function. Okay? This is for working in teams. This is for giving a hint to another developer who will check your code, who will go through your code, and you don't want him to lose any more time to understand your code. Okay? So, about the arguments. What are the ideal number of arguments a function should have? The type of arguments should we use or avoid? And about linear independence of arguments. So any one of you can tell what is the ideal number of a function? Anyone? 0. 1. 7. Okay, and it goes like this. Ideal number of arguments for a function is 0. Well, this is from a book, but that book was about Java. And I do understand this. This makes point. He says the number of arguments should be very few. Ideal case is 0. Why? Because in Java you always have class, you always have state inside of the class, and you have more data, not only the function, but the data inside the class. And in like many cases you can skip arguments. Yes, because function will use the arguments from inside its members. But we are writing in JavaScript, and I think for functional languages, the ideal number of arguments is 1. One argument, because 0 is not the case with functional programming, we don't want to use states outside of our function. We don't want to use global variables. We don't want to use global scopes. That's why we are passing argument to function to deal with it. And one argument function gives us a guarantee that we can compose this function easily. Yes, we can easily understand that function. And we will later see the composition examples where one argument is a must. So I don't say that every time you can write function with one argument, but at least you should try to write functions with smaller number of arguments. In JavaScript, you can use objects to wrap your multiple variables into one object and still have one argument. In JavaScript, you can easily query function. You can take any 3-argument function and make 1-argument function with just querying technique. Querying, is it familiar from functional programming paradigms? Yeah, querying or partial application. Those 2 principles will help you. So, Booleans, about the type of arguments. This is also from the book, and it really has a real knowledge and real sense inside. It says that whenever you use Boolean as a function argument, you are yelling to the world that my function does 2 things, at least 2 things. It does one thing when the argument is true, and it does the other thing when the argument is false. Okay? But we know that function must do one thing, and he must do that one thing the best way. So there are exceptions, of course. If you want to save some state into the database, of course you should send that Boolean. But in all other cases, the recommendation is you better check your variable before calling the function. You write that if before calling the function. If this is true, then call save user function. If this is false, then remove user function. Okay? You extract the body into 2 different functions. You do not grab everything inside one function. And this is an indicator for you for when you will go and check your own code bases, check for Boolean arguments, and see if they are really representing a unified unit portion of program, or the function does 2 things. So linear independent argument, linearly independent. What does this mean? This is an example when we are coloring an SVG element. This is short version of function, just for example. We are receiving document, we are receiving SVG doc and ID, and we are filling that component with a color. But when you go and check the call of the function, you see that you are using document and something inside from the document. Okay? From the function body, it looks like it has 3 different arguments, but indeed you can skip this second argument and you can just send the document, which is enough. Linear independence is when your arguments are completely independent. Their states do not change. Their states are changed in parallel. And this is a good example to see that number of arguments can be reduced to 2. So you just send them document and the element name, which is completely enough because you can use document SVG inside the function. Okay? Then, about the purity. This talk could be called a functional programming talk or the best parts of functional programming in JavaScript. But still, this is called what it is, the saga of a single function. And the purity, we describe it as function is a pure if it depends only from its arguments. Yes? A pure function depends only from its arguments. It doesn't have side effects. It can be replaced by the key value table. And these pure functions, they are really helpful. They do not contain a lot of bugs in most cases. They help you to avoid nasty side effects, data modifications, global scope modifications. And I want to show you an example. For example, a simple function, you are checking is an adult or not, and you are checking if the age given to you is bigger than the minimum or not. It's a good function. It can work, no problem, no bug, everything is okay. But if at some point of time someone changes the minimum variable in the global scope, then your function will behave in a different way. That's why the best practice, the best advice is to have all the variables, all the parameters inside of a function. In this case, the pure version of the function. It contains everything it needs to know. It doesn't have any external dependencies. Any global scope change cannot modify this function behavior. It's very predictable. You check it one time and you forget about it forever. So other advantages. Pure functions are cacheable. If function depends only on its arguments, that function may be cached. Okay? I hope many of you have used caches of different sorts. Database cache, memory cache, function cache, object cache. Am I correct or not? Have you used cacheable functions, Redux selectors? Yeah? So the beauty is that if function has external dependencies or side effects, you can never cache them. And if you are doing a really big calculation inside of a function, you need to do this every time you call function. But with pure function, you just cache the result. Because you know if for this argument, this is the result throughout the whole history of humankind. Okay? It never changes. So you can cache the result and do not calculate it again, and again. So this is the memoirs. Self-documenting. Pure functions are self-documenting. They tell you about their behavior. They tell you about their dependencies. And there is nothing hidden when you are using the pure function. So let's check just one synthetic example. This is a sign up that saves the user and then sends a welcome message to user. This is the pure version. The save user had a hidden dependency from the database reference. But if you grab the database reference and use it, then this particular function might become pure. Okay? So, other advantages. Pure functions are testable. It's really easy. It's really easy to write tests on pure functions. Really, really easy. Because while dealing with side effects with database calls, anyone who has written tests knows that you need to write a lot of mocks, a lot of other helpful functions to be able to test your function. But pure functions are really easy to test. They can be run parallel. When I say parallel, I don't mean that your processor runs in parallel and does whatever weird stuff you have. This is about simple mappings. Maps, reduce, filter, whatever function or promises, those can be executed in parallel because they don't have global dependencies. They don't have shared memory. And it reduces the debug scope. What do I mean? Imagine you have like this big code base. this big part is a pure function, and you have a dirty part which works with user input and database. Yeah? Whenever something weird happens, you can leave and skip this pure function part, which should be the biggest part in your application, and you go and check the dirty part. When you separate those two, it's really easy to debug your code. So what is SemiPure function? What? This is my invention. I haven't seen anywhere, maybe there is. You see that minimum is still declared outside. But what I mean when I say SemiPure function, if you are using any configuration file in which you have a constant with minimum age, and you are using that minimum age inside of a function, that can be treated or that can be named as a semi-pure. Because throughout the whole application lifecycle, the value of minimum age doesn't change. It can be treated as a pure function, and it can be tested the same way you test the pure function. An example of composition, when we are doing different modifications on the data, I have placed an illustration which shows a production line. The composition is really similar to production line. You take the data, you transform it into another data, you add some user data, you remove some unused fields, then you transform it into an XML format, and you send it back. So it's a production line. Each step is independent. Each step has its unique input and its output, and its output. And these types of functions, which are, you see, every function has one argument. It takes one argument, returns one argument, takes one argument, returns one argument. Those can be composed with a compose function. There are a lot of implementations of compose function you can find everywhere on the internet. And this is the way to do. Yeah? Your data will flow from the right to the left. First, normalize, capitalize, remove. Or in this particular case, the other way around. Now, the other composition examples we used to see a lot, but we didn't think about it as a composition, which is an Express.js middleware. I hope a lot of you have written codes in Node.js and Express.js. This middleware structure and logic is the same way as a composition. Just it has three arguments: request, response, and next. This is another example. And one example from promises. This is a promise chain, but again, it represents composition, some sort of implementation of composition, because every callback you give to then is a function that receives one argument, returns one argument. Okay? When you are writing functions that are acting on one argument and returning one argument, you can make those kind of nice compositions. And it's not only nice, it's semantically correct, it's semantically informative. You can read what is going on inside the function. Yeah? You can read what is going on, in what order. If you want to know in which particular function what does happen, you go and check the function. But at least from the top level view, you can understand what is going on in general. Arrays and loops. I will go quickly because I have less time. I hope all of you know those functions. MapReduce, for each, find. Those functions are very helpful. They help us to write nice functional code. So one example of functional, wrong implementation of functional code, you can see that it takes an array and finds if an item is even, it returns like square of those numbers. Yeah? But if you check carefully, this function does two things. First, it checks out whether the number is even or not. Second, it squares the number. Now, the other implementation. You take an array, you filter the numbers that are even, and on the items that are left, you are making square. Okay? Nice, easy, simple. The other implementation, the same function, but now they have names. Name is, you took outside those functions and you give them names. It's even and power of 2. More readable, semantically correct, semantically meaningful information that no one can confuse this. You will read it and understand it like 100% without any problem. And my advice is whenever you have callbacks inside of a map, for each, filter, whatever, yeah, your body of the callback function grows, and grows. always the recommendation is this. Get this callback function out, name it, and remove it outside. Okay? This is very helpful. And I will show you an example here. This is the pure testable implementation of the example we saw earlier. You see, it again changes the element color, but it has all the dependencies it needs. It has the element getter, it has the color, and it has the index of the element. The element getter is a function which goes as an argument. So, and we will only left with 2 lines of dirty code. This is the dirty part where we used to have, where we cannot skip this SVG document. So we separated a big pure part and a little dirty part. And it will be really easy to debug this code going forward. About reduce, I will show you these quick examples. These are lines from all different functions that we are using. In one case, you are summing file size, file percent, file trim, start, end. But if you check carefully, you will see that there are a lot of repetitions. You are repeating the same thing over and over. Yeah. I suggest to have this kind of utility functions, basic sum function. No one needs this, yeah? But then you can use this sum function inside of reduce without writing the same thing over and over. And you can sum any property of an object from array just by using those kind of utility functions. And here is the old example, how to calculate the duration of screens. And this is the new example. Array, sum of object, durations. Okay, those 2 functions receive screens as arguments and return the same thing. Those are another examples, like percent the same way, size the same way. Final duration reduces array sum, just because it's just a sum of 2 numbers. Let me open this quickly. Before and the after. This was before and this is the after. The after is you end up with having a lot of small functions, small utility functions, and their calls. Calling a function is not a problem, but having a big body of a function is a problem. So you can call function like 100 of times, that's okay, but you should not have 100 lines of function. Okay? And those functions that are above the line, they are utilities that can be used in many, many other cases. My time is going, is just finishing. The general recommendation is that as we are writing JavaScript, we should remember that JavaScript utilizes a lot of functional programming paradigms, and you better make use of them, write functional style. Of course, there are libraries which do not allow us to do. First of all, it was Angular with its scope. The second thing which I don't really like, and I'm against of it, is the React hooks is against of this paradigm. So I don't like this React hooks. But whenever you can, you're writing functional style, and our experience of long years of programming has proven that those functions and those parts of application that are written in functional style, we never touch those. It never caused any problem, and it lives there like it doesn't even exist. Okay? Thank you very much.